Hello everyone, I am Nishita Namdev and welcome back to another YouTube video. Today we are here to solve the another problem which was asked in Google. The problem is the part of the premium problems of lead code. So I think that not everybody has the access to the problem, but we are going to solve this problem today, okay? So the problem statement is we need to find the longest substring with at most two distinct characters. So what is given to us? We have given a string s and we need to return the length of the longest substring which can have at most two distinguishable characters in it. Okay, let's try to understand it with an example. We have given an input string s and the string is ECEBA. These are the characters of the string, and let's try to find out the longest substring we can have in it, which has the two distinguishable characters at most. Let's see, first we have E, then we have C. These are the two distinguishable characters, right? Then we again have E. So it is the similar character, right? So this is the longest substring that we can get from this string. And we need to return the length of the string. So the length of the string would be 3. Let's understand it with another example. So we have the string which is the second string. The string is C, C, A, and triple B. Let's iterate through the string. First we have C, then we have C. This is the one character, right? This is the one character. Then we have A, and again we have A. So this could be the longest substring, right? We only have two distinguishable characters, and the length of this string is 4. Okay, let's move again. Then we got B. This is the third distinguishable character. So what we are going to do, we are going to drop this first C, right? We will move from C, A, B. Again, we get B. Again, we are having three different characters, right? But we only want two. So let's drop the C again. We will move from A, and triple B. We in this substring we have at most two different characters which are A and B, and the longest substring that we can get from this string is of the length 5, right? So this is our answer. So that's what the problem is, and let's move on to the solution part of the problem. First of all, I'm going to tell you that we are going to use a sliding window technique to solve this problem. So basically in sliding window technique, we use two pointers to iterate throughout the string or the arrays or the linked list, whatever you have. So, and what we try to do, we try to iterate throughout the string by using the pointers, and we try to solve the problem with it. So we are going to use the sliding window technique here. First of all, we are going to create a variable. Let me write the code for it. I have created a variable n, which is of the type integer, and I have assigned it with the length of the string. The variable basically holds the length of this input string given to us. Then we are going to check by an if condition. What is the if condition is all about? So the if condition says if the length of the string is less than 3, we are going to simply return the string itself, which means we are simply going to return the length of the string itself. So why are we doing this? Because the condition is given to us that the string can contain at most two distinguishable characters. So if we have a string which has only two characters in it, so it doesn't mean if the characters are same or not. It is anyways going to fulfill the condition of our problem, right? So we are going to simply returning the length of the given string if its length is less than 3. Okay, then we are going to create two pointers, right? Because we are going to solve this problem with the sliding window technique. So we need two pointers. These are the two pointers by the name left and right, and both are assigned to 0, which means both these pointers will be at this position initially. Okay. Next, we are going to make a hash map. Why are we making a hash map? Because we need to store the values of the string, right? We need to store these characters in our hash map. Why do we need to store it? So that we can get what character we are visiting, because we need to get to know how many distinguishable characters are there, right? That's why we are storing the values of these characters into our hash map. So we are going to store E, like the characters, as the keys, and we are going to store the positions of these characters as values. Okay. So this is our hash map. Don't worry, I'm gonna dry run this code after writing the whole code. Okay, so you will understand how the problem is being solved by using the hash map and the two pointers. Next, we are gonna mm, make a variable by the name max length, and we will assign it to 2 because this is the minimum condition, this is the minimum length we require to solve our problem. Our string should be of the minimum length 2, right? That's why we are assigning the variable with 2. Okay, this is the max length variable. What is going to store? It is going to store the maximum length we can get from the given string. The maximum length of a substring we can get, it's going to store, the variable is going to store the length in it. Then we are also going to create a variable int k equals to 2. What this variable is going to do, we defined k as 2 because it represents the maximum number of distinguishable characters allowed in the substring. We're going to use this variable. That's why we have made this variable right now, and we have assigned it to 2. Okay. Why did we assign it to 2? Because this is the maximum number of distinct characters that are allowed in our substring, right? Then we are going to make a while loop. Okay. Why we are going to use the while loop? Because we need to iterate throughout the string to get to know what are the characters which are there in the string, right? So we are writing a while loop. And what's the condition in the while loop? It says the right pointer should be less than n. N is basically the length of the whole string. And the right pointer that we have created, it should be less than n, which basically means the right pointer will iterate throughout the string. Okay. Then what we are doing, this is an important line that I'm going to write next. Okay. So what we have done, I have written hash map.put as.char at right, and we are also increasing right. What does it mean? It simply means that whatever the right pointer is at, our right pointer is at this position initially, at whatever position our right pointer is at, we simply need to put that character and its position into the hash map. Basically, we are storing the positions and the characters into our hash map by this line. Okay. And we are also increasing the right pointer so that we can iterate throughout the string, right? We need to visit other places too. That's why we are increasing it. Okay, we are here with our if condition, right? What does the if condition says? First of all, it is checking what is the size of the hash map. Initially, we have initialized k with 2, which basically means our hash map should be of the size 2. It should have at least 2 characters in it, 2 distinguishable characters in it. Okay. So it is checking that if the size increases by 1, which means our hash map has 3 characters in it, which basically means 3 distinguishable characters, right? Which is against the condition we have given. We are given with uh, at most we can have only 2 distinguishable characters. But if the hash map increases the size, if it has more than 2 characters, what we are going to do? We have also initialized another variable del index, delete index basically, which means delete index. It is the short form of delete. So del index, and we are removing the we are identifying what is the least value our hash map has. Okay, it is identifying what is the least value our hash map has, and it is removing that character. Okay, then it is increasing the left pointer by 1. This is what this if condition is doing. And in the end, we are gonna calculate our maximum length. So this is how we are going to calculate what our maximum length is. Math.max, we will calculate the maximum length by subtracting the position of the right pointer and the left pointer. Okay. And simply we will return the maximum length as our answer. I guess I missed one parenthesis. I think yes, we do not have the parenthesis of while loop. Yes, and I'm gonna return the maximum length. Okay, this is our code. Now I'm gonna dry run this code so that you understand what we are actually doing. Let's understand with this example. We have this string ECEBA. We need to iterate throughout the string and we need to find the longest substring without uh, having more than 3 distinguishable characters, right? We can only have 2 distinguishable characters in it. What we are going to do? First of all, we are gonna make 2 pointers, left and right, and we initialized both the pointers with 0. So both the pointers will be at position this. Okay. First of all, we will use the right pointer to iterate throughout the string and to store the values into our hash map. How we are going to store the values into our hash map? We are storing the characters as keys and we are storing the position of the characters as values. Okay. So first of all, our right pointer will move to this character E, and it will check whether the character exists in our hash map or not. It doesn't exist. It will simply store the character and its position into the hash map. Okay. How it's gonna store? It will simply say like this: E is stored and E is equal to 0. Okay, these are the key value pairs. Then it is going to move to C. It will check C exists our whether our hash map has a maximum 2 characters or not. No, it has only 1 character. This is the condition that we have put here, right? If it exceeds 2 characters, but we have the only 1 character in our hash map, so it simply means we can store one more character in it, right? So it is going to store C. C equals to 1. It will store it like this. Okay, because the C is at the position 1. Okay, then it is going to move to E again. What is going to do? It will update the position of E because E is at position 2. So it is going to update the position of E. And now these are the characters that is there in your hash map. Then the right pointer will move to B. What happens when it moves to B? It is going to store the B into our hash map with its position. What's the position? It's 3. It is going to store the character into the hash map, right? The character is being stored, but it will enter into this if loop, if condition. Sorry, not the loop. If is a condition. It is going to enter into this if condition. Why is it going to enter this in this condition? Because we have put the condition that if the size of the hash map increases, if it gets greater than 2, k is simply 2 because we have initialized it to 2, and if gets k plus 1 means if the size gets 3, what we are going to do? And a variable delete index is going to find out which is the variable in the whole index which has the least value. What is going to do? It is going to find out whatever characters we have stored in our hash map, what is that character which has the least value. What's that character? It's C, right? C has the least value because C is stored as a key, and one which is C's position is stored as a value, right? So C has value 1. It is going to delete that character. The next line says hash map dot remove whatever character in the S string, whatever character we have in the S string, delete that index. The index that this variable has find out in our hash map, which has the least value, delete it from the hash map, remove it from the hash map. So it is going to remove C from the hash map. Now again, the condition satisfied. At most, we have only 2 distinguishable variables in our hash map, right? And after that, it is also going to increase our left pointer by 1. Not by 1, by whatever the index we have deleted. The index that we have deleted is 1, right? Because C has the position 1, the value 1. So 1 plus 1, 2. The left character, I'm going to write a comment here. So left pointer will become 1 plus 1 equal to 2, because the deleted index, that the index that we have deleted was the index 1, which is basically the position of c, so it is going to increase by 1. So 1 is the value of deleted index, and we have already written 1 here, so 1 plus 1 is 2. So left character will move to 2. 0 1 2, the left character will move to e. Okay, now it's going to check again, going into the while loop, and it is going to check whether we have any other characters left in the string or not. Our right pointer will move to a. Okay, and it is going to store a in the hash map. A equals to, what's the position again? 4, I guess. 0 1 2 3 4. Yes, a has the position 4. It is going to store this variable into the hash map. See, we get into the while loop. We checked whether our right pointer is less than the length of the string. No, our right pointer was at b. We have the length remaining, right? We have the length remaining. So our right pointer will move towards a. After that, it is going to store the value of a into our hash map. It stored the value and the position of the a. Then, if the hash map has a the value greater than 3, if if the size of the hash map increases by 3, it is gonna, again, the del index, which is the variable, it is gonna find out what is the least value we have in our hash map. So the size of the hash map increased by 3, right? So the delete index is gonna find out what is the least value we have in our hash map. It is gonna delete this e, because the e has the least value. I forgot one thing to tell you. Before moving again into the while loop, before moving to a, we are also increasing the length. We are also calculating. It was at 2, then it is going to become 3, right? It will become 3, and our right pointer was at 0 1 2 3 4. Our right pointer was at 4. So 4 minus 3 is 1. So this is how we are going to store the values in our hash map, and how is this is how is it going to store and remove the values, so that we can get the desired results. We are calculating the maximum length by minusing the value of the left pointer from the current position of the right pointer. Okay, and simply we are returning max length, a variable, in the end, right? Let's see if this code works or not. Let's click on run. And these are the three examples that we have taken to get to know whether the code is working fine or not. It is working fine. We got the results as 355, which are the correct outputs. So this is pretty much about the code. And I really hope that you liked our video, you understood how the code is working. And let's meet in the another video. Bye.